when you have a graph, they can ask you a lot of questions. So we focus on the previous sessions to be able to draw graphs of various motion, whether starts from the origin or starting from particular point of the time. So now let's look at some of the questions that they may ask us. One popular question they may ask you is calculate the acceleration or deceleration at different points. Let's get this. Whenever the slope is going up, whenever there is slope, that's where acceleration is happening in a velocity time graph. So whenever the slope is going up from down up, that side is acceleration. So we call it, this is the acceleration we have. Right? But whenever it is going down, like from up going down, this is where you have a deceleration. And in acceleration, the final answer will be positive. To be a positive answer, in deceleration, the answer will be a negative answer. But how do you find deceleration? Let's push that acceleration. So when you have an acceleration, we are going to use A to represent acceleration, the formula. So acceleration A is equal to change in the velocity over the change in time. So change in the velocity is basically the final velocity minus the initial velocity all over the final time minus the initial time. So this is what you have to do. Always the final minus initial for the top of velocities, the final minus initial for the down. When you evaluate it and you have a negative value, then that should be an acceleration. When you do the operation, you have a positive value, that should be an acceleration. That's from the value. But then from the graph, you can easily tell whether it's going to be acceleration or deceleration. Acceleration when it's going up, and the deceleration when it's going down. Let's start looking at the question that we solved before. Starting from the very first one is, so we are assuming that this all the time velocity and meters per second and our time side is second. That's the assumption that we are having. So you have to look at the question. If they say kilometers per hour, they are working with hour against hour, or kilometers per hour against hour, or meters per second against second. You have to look at that. But here, you're going to be the very basic one, the most popular one, which is meters per second for velocity for time is seconds. So here we see that our graph is going from down up. So that will be an acceleration. So but how do we evaluate that? So A will be equal to change in velocity over change in time. We say going to change in velocity over change in time. Change in velocity is, we say final minus initial. So if you look at this, the final velocity that we get to at this point from here to this point, the final velocity that we get to, the final V is 20. So that's V of, so 20 minus the initial. Where do we start from? We started from a 0.0. 20, 0 over the time to the final time where you reach over here is 5. So you go to final time minus initial time. We started the time from 0 to initial time equal to 0. That will be 20. The top will give us which the bottom will give us 5. And the final answer will be 20 over that 5. That will be 4. And then the unit will be meters per second squared. It's acceleration. Acceleration is measured in distance per second squared. So here is meters per second squared. If it's the other ones will also follow the time accordingly. But then the basic one is meters per second squared. So it's acceleration. So you have points answer the A. Let's look at this one. This is from 30, right? 30 to rest. And the rest here at the rest, the velocity is 0. The time is also 0. So let's start that. So what are we calculating? Let's try to evaluate whatever we had here. So change in velocity over change in time. So that will be equal to final velocity, Vf. Be careful here. What we are getting to finally, that's the final velocity. So we are getting to 0, not start with 30. Because the final velocity in this case will be 0. So 0 minus 30, right? Vf minus Vi. We started from here. Vi is V initial, that's the starting point. We started from here and ended here. And the velocity as is 0 at this point, but here is 30. So what about the time? The time is always the final time, which is 6 minus initial time, which is 0. Then we have 30 over 6. 30 over 6 is going to give us 5. And the unit is meters per second squared again. Okay. Now let's go here. So you see this graph from here to here. You can see that there is slope happening here. There is slope happening here. But this one is horizontal. This one is not going up or down. So there's not going to be any acceleration or deceleration by here. This is horizontal. But here, this one is, you see, it's going up. Since it's going up as acceleration, so we are going to calculate acceleration here. If you ask you for the acceleration over here, it's going to be 0. But we need to use this example to give to y 0. So let's first calculate the acceleration for this side. So it's going to be change in v over change in t. And then v is v final. The the final velocity from here to here, the final velocity here is 15 minus 0. But that 0 is where we start from. The time at this point is 3. So it's 3 minus 0. And you have 15 over 3. That will be equal to 5 meters per second square. So now that we have this, what's the next one? Let's explain why this one is equal to 0. Let's explain why this one is equal to 0. So if you consider only the horizontal line, the formula is change in v over change in time, right? It's vf minus vi all over tf minus ti. Final velocity at this point, so we are here, right? And we are getting the destination on this horizontal line. What we get here, the final velocity that we are having, the velocity are always measured on the horizontal, so it's 15, right? Minus what the starting point. The starting point is here. It's also linked to the same 15. You can't 15 minus 15 at all. So we initial and final are the same. But the time is what? The final time here is 7 minus the initial time here is 3. So at the end of 15 over minus 15 is 0 over 4. And 0 over 4 is 0. So whenever it is horizontal, the velocity is 0. The acceleration is 0. Acceleration is 0. So we don't even bother to calculate for horizontal stuff. That's why we focus on the one that slope up or slope down, like this question. So here we are going to experience acceleration over here and experience deceleration over here before it's going down. So let's calculate the acceleration here. So you calculate the acceleration, you are going to have final velocity is 20 minus 0 over final time is 4 minus 0. That is going to go to about 5 meters per second squared. You are not going to calculate for this because it's horizontal and there's no acceleration happening here. But here it's going down, so there's going to be deceleration. We are expecting the negative value from this point. So for this particular point, it's going to be final, right? Final velocity will be 0. Is it the velocity I'm measuring on the horizontal line on the vertical axis, and to 0 minus 20 all over. The time is final time is 15, but then this deceleration started from this point 10. So it's going to be 15 minus 10, which is given us negative 20 over 5. Negative 20 over 5 is going to give a negative 4 meters per second square. So the negative tells us that it's a deceleration that is happening over there. There's another question. So yeah, this is what we take our time to explain the other time, right? Let's calculate acceleration and deceleration at the various point where they have to occur. We know that acceleration is going to, what the acceleration on this point at this point, right? What the acceleration here, what the acceleration. We know that for the horizontal one is going to be 0, so the acceleration is going to be 0 because the velocity is always constant on the horizontal component of the graph. So, but then what is happening here? What is happening here is going to be an acceleration as well. So you are going to have a final which is moving from here to here on this part. We are going to have 25 velocity minus final, which is 10 all over the time. The time here is any time is 5 minus 0. 0 in the beginning. So we have 25 minus 10. We are getting 15 over 5. That's going to give us 3 meters per second squared. So 3 meters per second squared, the acceleration that happened over here. Now let's get to this one. It's going to be deceleration, right? So the deceleration is final. Finally, we are here, right? There is a final destination for this deceleration part. So we move from up and down to the final part of this side. If this side, the velocity corresponding to that side is 15. So V final, which is 15 minus what we started from the top here is 25, corresponding to 25 all over. Now that the time is 15 here minus where this one started is 11. So we are going to have 15 minus 25 is going to give us negative 10 divided by 15 minus 11 is going to give us 4, right? So if you give us 4, it's going to give us negative 2.5. That's the answer for this particular question. Negative 2.5 meters per second squared. So try and solve for this one, right? The one we solved and then in the previous session. We drew the graph for this one. So that's what we do. We try to solve the question for this. You can pause and take notes of it and then practice yourself. And then let's see how good you are with that concept. And then there's another one here. This is the final one that we also looked at in our previous sessions when we're drawing the graph. And then we have the graph. You should be able to draw using this concept to get the acceleration and deceleration of everything that we have here. Yeah. Let's meet in the next session and look at another calculation that is possible on graph of motion.